day, grade 8 learners. In this video, you are going to learn about operations on rational algebraic expressions. You will learn about Module 5, Lesson 4. Adding and subtracting dissimilar rational algebraic expressions. What I need to know. At the end of the lesson, you are expected to demonstrate understanding of the key concepts of adding and subtracting dissimilar rational algebraic expressions and add and subtract dissimilar rational algebraic expressions. What's in? This time, let's have a review about the addition and subtraction of dissimilar fractions. Just take note that as we add and subtract dissimilar fractions, we need to get the LCD. LCD stands for least common denominator, which means the smallest whole number that is divisible by each of the denominator. So how to get the LCD? So we just simply list the multiples of each denominator. It could be multiplied by 2, 3, 4, or etc. Then, look for the smallest number that appears in each list and make sure that smallest number is common to both of them. And that is the LCD. Let's have this example, addition of similar fractions. Number 1, 3 over 4 plus 2 over 5. It is dissimilar because they don't have the same denominator. Since they don't have the same denominator, we have to get the LCD. And to get the LCD, we need to get the multiples of 4 and 5. So we have here the multiples of 4 are 4, 8, 12, 16, 20, 24, 28. And the multiples of 5 are 5, 10, 15, 20, 25, 30. And as you can see, the least common number for both 4 and 5 is 20. Therefore, it is our least common denominator. So we already got our LCD, which is equal to 20, so we put that in our denominator and just copy our operation sign, which is addition. And this time, let's evaluate to both fractions. So 20 divided by 4 is equal to 5 times 3 is equal to 15. Now let's divide 20 divided by 5 is equal to 4 times 2 is equal to 8. So our new expression will become 15 plus 8 over 20, or simply 23 over 20. And take note that we always need to express our answer to its simplest form. But in this case, we cannot simplify 23 over 20 to its simplest form anymore. So that is our final answer. Now let's have number 2. 5 over 2 minus 2 over 7. Now let's get the multiples of 2 and 7 to get our least common denominator. So we have here the multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, and so on. We also have the multiples of 7, 7, 14, 21. So in this case, our least common denominator is 14. Just take note that if you can already get the least common denominator, you don't have to get the multiples until 100s or 200s, because our goal is just to get the LCD. Now let's evaluate. So we just have to put our LCD in the denominator and copy the operation, which is subtraction, in the numerator, and then evaluate the fraction. So we will just divide 14. 14 divided by 2 is equal to 7 times 5 is equal to 35. Then let's divide 14 divided by 7 is equal to 2 times 2 is equal to 4. So we have here 35 minus 4 over 14, or simply 31 over 14. And since we cannot simplify 31 over 14 to its lowest term, so our final answer is 31 over 14. What's new? Let's find out the process of getting the answer of this rational algebraic expression. 5y over 6 minus 2x over 3y cubed is equal to 5y to the power of 4 minus 4x over 6y cubed. What is it? How to add and subtract dissimilar rational algebraic expressions? Let's remember this rule. In adding or subtracting dissimilar rational expressions, change the rational algebraic expressions into similar rational algebraic expressions using the least common denominator, or LCD, and proceed as in adding or subtracting similar fractions. Let's have this example number 1. Find the sum of 5 over 18a to the power of 4 times b and 2 over 27a cubed times b squared times c. At the least common denominator of the addends, 18a to the power of 4 times b and 27a cubed b squared times c. So their least common denominator is 54a to the power of 4 times b squared times c. So for 54, you already know how to get the multiples of 18 and 27. So the least common, that is the LCD. And for the literal coefficients, for a to the power of 4 b squared c, according to the rule, if there are variables which has the same base, then all you have to do is just to get the highest exponent. Yes, so get the factor with the highest exponent, and then that is already the LCD for the literal coefficient. And now let's simplify. So 54 times 18 is equal to 3, and then times 5 is equal to 15, and we also have for the literal coefficient a to the power of 4 b squared times c divided by a to the power of 4 times b. And applying the power of quotient, so we got here bc. Next, 54a to the power of 4 b squared c divided by 27a cubed b squared c is equal to 2a. So 2a times 2 is equal to 4a. So we got here 15bc plus 4a over 54a to the power of 4 b squared c. Therefore, 5 over 18a to the power of 4 times b plus 2 over 27a cubed times b squared times c is equal to 15bc plus 4a over 54a to the power of 4b squared c. Now let's have number 2. Subtract t plus 3 over t squared minus 6t plus 9 and 8t minus 24 over t squared minus 9. So in this case, we cannot easily get the LCD because we still have to factor out the denominator, the t squared minus 6t plus 9 and the t squared minus 9. So for t squared minus 6t plus 9, we can factor this out since it is a perfect square trinomial. And for t squared minus 9, we just have to use the difference of squares in factoring it out. So we will be able to get the new equation is t plus 3 over the quantity of t minus 3 squared minus 8t minus 24 over the quantity of t minus 3 times the quantity of t plus 3. Now we will be able to get the LCD of this denominator. And the LCD of this denominator is the quantity of t minus 3 squared times the quantity of t plus 3. So since t minus 3 is common, then as part of the rule in getting the LCD, get the factor which has the highest exponent. So that's why we got the quantity of t minus 3 squared and just copy t plus 3. And now we can already simplify just like the previous steps. So we have here the quantity of t minus 3 squared times the quantity of t plus 3 divided by the quantity of t minus 3 squared. So it means it will be cancelled out. So we will have the remaining t plus 3. So t plus 3 times t plus 3, it will become the quantity of t plus 3 squared. And for the other expression, we have the quantity of t minus 3 squared times the quantity of t plus 3 divided by the quantity of t minus 3 times the quantity of t plus 3. So we will be able to cancel out t plus 3 and then just minus the exponent of t minus 3, the quantity of t minus 3. So the remaining one is t minus 3 times 8t minus 24. So we will be able to have this new expression, the quantity of t plus 3 squared minus the quantity of t minus 3 times the quantity of 8t minus 24 over the LCD, the quantity of t minus 3 squared times the quantity of t plus 3. Now we need to expand the expression in the numerator and also in the denominator to simplify. And how to expand? We just have to follow the FOIL method. I hope you still remember. So for the numerator, we will be able to expand it and we will have the result for the quantity of t plus 3 squared. We will get the quantity of t squared plus 6t plus 9, and for this equation, t minus 3 times the quantity of 8t minus 24, we will be able to get 8t squared minus 48t plus 72. So it is enclosed with parentheses. over, just copy the denominator, the quantity of t minus 3 squared times the quantity of t plus 3. Now, let's expand also the denominator since we can still expand this using the FOIL method. So we will be able to get t squared minus 6t minus 9 times the quantity of t plus 3. And for the numerator, we just distributed the negative to this expression. So we will have this negative t squared plus 48t minus 72. So our new expression is the quantity of t squared plus 6t plus 9 minus 8t squared plus 48t minus 72 over t squared minus 6t minus 9 times the quantity of t plus 3. Now, let's continue expanding our numerator and denominator since we can still expand this one. So, we will be able to have t squared plus 6t plus 9 minus 8t squared plus 48t minus 72 over 8 cubed minus 68 squared plus 9t plus 3t squared minus 18t plus 27. So we just distributed t plus 3 to t squared minus 6t minus 9. So after expanding the factors in the numerator and denominator, let's now combine like terms if there are some like terms and then evaluate. So for the numerator, we have t squared negative 8t squared. We also have 6t and 48t. So we also have 9 and negative 72. So those are our common terms in the numerator. And now, let's evaluate our numerator. So, as we evaluate, t squared minus 8t squared is equal to negative 7t squared. And we have here 6t plus 48t is we have here 54t. And for the last term, we have here positive 9 minus 72 is equal to negative 63. So our numerator will become negative 7t squared plus 54t minus 63 over 8 cubed minus 6t squared plus 9t plus 3t squared minus 18t plus 27. Now let's proceed in evaluating our denominator. So we still also have to combine the like terms. So we have here negative 6t squared and positive 3t squared. So another common terms in the denominator is 9t and negative 18t. So let's evaluate. So we just copied t cubed since there is no other common term in the denominator. and evaluate negative 6t squared plus 3t squared is equal to negative 3t squared. We also have 9t minus 18t, and we got here negative 9t, and copy the constant 27. And since we cannot simplify anymore, negative 7t squared plus 54t minus 63 over t cubed minus 3t squared minus 9t plus 27. Therefore, it is the final answer. You were able to learn adding and subtracting dissimilar rational algebraic expressions. And now, let's have a practice on that one. What's more? Directions. Answer the activity below to measure your understanding about the lesson. Use a separate sheet of paper for your answers. Activity 1.4. Perform the indicated operation. Express your answers in simplest form. So we have here number 1, 3 over x plus 1 plus 4 over x. Number 2, x plus 8 over x squared minus 4x plus 4 plus 3x minus 2 over x squared minus 4. We also have number 3, 3 over x squared minus x minus 2 minus 2 over x squared minus 5x plus 6. Number 4, we have x minus 6 over x minus 4 plus 3x over 6x cubed plus 36x squared. And the last number, 5, 5x over x minus 5 minus 3 over 2x minus 1. Good luck in answering, and I know you will be able to do it. Just remember, this rule in adding or subtracting dissimilar rational expressions. Change the rational algebraic expressions into similar rational algebraic expressions using the least common denominator or LCD, and proceed as in adding or subtracting similar fractions. Do not forget this one. Now, to end this lesson, here's a quotation from B.J. Gupta. Hard work doesn't guarantee success, but it improves chances. So just keep doing your best, especially in answering about mathematics. I hope you learned something from this lesson.